pure but contains small amounts of unwanted impurities, and we need to separate that solid into a pure, crystalline state. The entire process hinges on one critical concept, the saturated solution. Think of a saturated solution as a chemical capacity limit. By definition, it is a solution that has dissolved every possible bit of solid it can hold at a specific temperature. In other words, the solvent is completely full. Every drop of liquid is already working as hard as it can just to keep the solid in a dissolved state. If you were to add even one more grain of solid to this mixture, it wouldn't dissolve, it would simply sink to the bottom. Understanding this limit is vital because, in recrystallization, we are going to manipulate this fullness to force our desired substance out of the liquid and into a pure solid form. There are two primary ways we prepare this. First, room temperature method, adding solid to a solvent at room temperature until it simply stops dissolving. Second, the hot method, adding just enough boiling or hot solvent to melt that solid into the liquid. Why does this matter? Because for recrystallization to work, the solution must be saturated only with the substance you want. We want our impurities to stay in the liquid, not join the crystal party. Once we have prepared our saturated solution, we begin